Hey guys, okay, let's do the video for 3-21. I'm going to do 3 examples on 3-21. These are just some different word problems. They tend to pop up on standardized tests. Um, Hopefully you guys can get familiar with them so this way you can be more successful in those types of tests. Some of them are pretty neat and challenging. All right, let's take a look. So this one is basically an ice cream cone. An ice cream cone is a hemisphere and a cone, um, all filled up, right? So I'm going to start with the hemisphere. The volume of a sphere is V equals 4/3 pi r cubed. The diameter of this hemisphere is 12. So I need the radius. So I'm going to say V equals 4/3 pi 6 cubed. 6 cubed, according to my calculator, whoops, is not syntax error. 6 cubed is 216. So V equals 4/3 pi 216. 216 times 4 divided by 3 is 288. V equals 288 pi. But that is of a whole sphere. So I have to divide this by 2. 288 divided by 2 is 144, but I'm going to double check that, and I am right. V equals 144 pi. So this is the volume of the hemisphere, or the top part. So I found the volume of this part of the ice cream cone. Now I'm going to find the rest. The volume of a cone is V equals 1/3 big B times H. Big B, let's remember, is the area of the base. So I have to find the area of this base, or the top of the cone. But if we flipped it over, it'd be the base of the cone. The base of this cone is a circle. To find the area of a circle, we use pi r squared. I'm going to plug that in. V equals 1/3 pi r squared times h. The height is 12, and the radius is 6. So that's 1/3 times 6 squared times 12. That's V equals 1/3 pi 36 times 12. Let's plug that in. 36 times 12 times 1. Ooh, I almost divided it. Let's try it this way. 1/3. Come on. There we go. Times 36 times 12. And just as I mentioned in the other videos, the pi comes along for the ride. That's all we're worried about. This too comes out to be 144 pi. So this is the cylinder. It is just coincidental that they both came out the same way. That doesn't always happen. Now what I need to do is I need to add the cylinder plus the hemisphere. So that's 144 pi plus 144 pi. 144 plus 144 is 288 pi. Okay, that's that example. Okay, next. Okay, this is called a frustum. I can barely say the word. Okay, and this is it's basically a half-filled cone, and we have to find the volume of typically the shaded area, sometimes the unshaded area, but the process is the same. It is way more complicated than it looks, but there are a couple of considerations we have to take. Basically what I have to do is I have to find the volume of the entire cone together, then subtract the small cone from it. Alright, so that's how I get the volume of the shaded area. So the first thing I have to recognize is that this entire height is 14. Okay, and keep in mind I have two different radiuses here. 3 for the smaller and 7 for the bigger. Alright, so the volume of a cone is 1/3 big B times H. Remember, this is important, big B is the area of the base. I'm going to do the small guy first. So let's do the small. And what I'm doing is I'm doing this top part here. Alright, so this is going to be small. I'm going to actually label it so you can kind of see what I'm doing. This is small. So this is V equals 1/3 pi 3 squared times 6. I punched in pi r squared into here because these are both cones. So I'm going to be using pi r squared times h. Pi r squared is the area of a circle, and the base of the cone is a circle. So now I have V equals 1/3 times pi 9 times 6. I'm going to plug that all in together. So let's do that. 1/3 times 9 times 6. And I get 18 pi. This is the small cone. Small cone. Now I have to find the area of the big cone, or the whole cone. So let's find the area of the big cone. Okay, or volume, excuse me, the volume of the big cone. So V equals 1/3. All right, we're going to use pi r squared again because the shape of that base is a circle. I have a radius of 7. 7 squared times 14. V equals 1/3 times pi times 49 times 14. Let's plug that all in together. So, whoop, I don't need that 1/3 there. I'm plugging it in here. So it's 1/3 times 49 times 14. And that is going to be 686 over 3 pi. 686 over 3 pi. And that is the big cone. Now what I have to do is I have to subtract the big cone and the small cone. Okay. The big cone is 686 over 3 pi, and the small cone is 18 pi. I'm going to see if I can get this to work. 686 over 3 minus 18. And I got 632 over 3. Okay, so the answer is 632 over 3 pi. That is the volume of the shaded area. So let me just recap here real quickly. I had to find the volume of a cone. So big B equaled pi r squared, so I plugged that in. I found the volume of the small cone, which was this unshaded region. I found the volume of the big cone by adding those two heights together and using that radius. Then I subtracted them to get that answer. All right, last example. This isn't a volume question. It's a circles question. It's actually a sector area question. But I want to go over it because we really haven't done it. It's worth taking a look at. So it says here in the diagram below, AC and BD are arcs of a concentric circle. all a concentric circle is a circle within a circle. The radius OA is 4 centimeters and the radius OD is 7 centimeters. Find the shaded area. All right, let's see here. So the radius OA is 4 centimeters. So this is 4. The radius OD, that's from here to here, is 7. And we just got to find the area of the shaded region, which is this, right? Okay. How did we do that? So we said sector area equals pi r squared times theta over 360. That's what we used. So I'm going to do that. I'm going to say, first I'm going to do, just like we did with the last example, first I'm going to do the small sector. And that's going to be sector area equals pi times 4 squared times 75 over 360. I am just plugging that sucker right into the calculator. All right. 4 squared times 75 over 360. So that sector area of the smaller guy is 10 over 3 pi. That's the small sector. I'm trying to label them twice so I can make sure you guys, just try to make sure you guys see what's going on. Okay, let's do the big sector now. Let me move that down. I think it could have fallen off the camera just a little bit. Alrighty, back on here. So now this is the big sector. Alright, that's sector area equals pi r squared times theta over 360. I always like to write the formula out, then plug it in. It makes it easier for me. So that sector area equals pi 7 squared times 75 over 360. Now I'm going to plug that right into the calculator. So let's do that. 7 squared. Let me use the fraction button first. 7 squared times 75 over 360. And that's 245 over 24. 245 over 24 pi. Okay, so that's the big sector. So before I move forward, let's just understand what I did. I found the area of the small sector, then I found the area of the big sector in order to be able to subtract them so I could find the shaded region. And that's what we're going to do. So big sector minus small sector. The big sector is 245 over 24 pi minus 10 over 3 pi. Again, don't get all blown away by these fractions and symbols. The calculator does most of the work, and pi just comes along for the ride. That's all he does. So we're going to say 245 over 24 minus 10 over 3. And I got 55 over 8 pi. Done. Okay, that is the volume of the shaded region. Alright guys, I hope you guys found these videos helpful.